Today we shall discuss about the electric dipole. What is electric dipole? If two equal and opposite charges are separated by a small distance, then the system is called an electric dipole. Okay, let two charges plus q and minus q is separated by a small distance 2d. Minus q and plus q are separated by a small distance 2d. I have taken it 2d for the simplification of the calculation. You may take it as d. Okay, so if two equal and opposite charges are separated by a small distance, then the system is called an electric dipole. For example, you may take axial. So this is delta negative, this portion is delta negative, and this is delta positive. So it forms an electric dipole. Okay, the dipole moment of an electric dipole is defined as the product of either of the magnitude of either of the charge and the separation distance between them. So the electric dipole moment is given by P equal to product of any of the charge and the separation distance between them. Electric dipole moment is a vector quantity. And the direction of the vector is given from the negative charge towards the positive charge. It is directed from negative to positive. Okay. In this case of HCl, it is directed from chlorine to hydrogen. Okay. So this is the definition of electric dipole moment. Now we have to find out the electric field due to this dipole at its any axial position and also at a point on its equatorial plane. Okay. So first take the case of axial point. So this is the dipole moment. Similarly, we have taken two charges minus q and plus q separated by a distance 2d. Suppose this is the midpoint of the dipole. Take it A. And so this is the axis of the dipole. And we have a point P at a distance x from the center. X from the origin or the center of the dipole. Okay. So this distance is x. We are interested to find out the electric field at the point P. So I am repeating again. This is the axis. So P is a point. P is any point on its axis. So we are interested to find out the electric field at its axial position. Okay. Now, to find out the electric field, we have to imagine 1 coulomb charge at the point P plus 1 coulomb charge at the point P. Now, this plus Q will repel this 1 coulomb charge in this direction. So this is E plus. That means electric field due to plus Q charge. And this minus Q will attract this in this direction. So this is E minus. Okay. Now what is the value of E plus? Magnitude of E plus is 1 by 4 pi epsilon naught into 1 into Q, that is Q, by distance. So this is X. So this is D, as O is the midpoint of A and B. So this is X minus D. Okay. So X minus D whole square along AB. That means along the dipole moment. This is the direction of the dipole moment. Now, what is the magnitude of E minus? It is 1 by 4 pi epsilon naught. Q1, Q2, that is minus Q into 1. Q into 1 divided by distance. So this is x plus d. So x plus d whole square along BA. Along BA. That means why along BA? You have noted that I haven't used the minus sign here. Okay, because I have represented the direction along. I have represented the direction along BA, not along AB. Okay, so the net electric field E equal to, so you may write it as along AB. Now the net electric field E equal to E plus E minus, that is equal to okay. Along AB. So this is equal to 1 by 4 pi epsilon naught. Take Q. This is x plus d whole square into x minus d whole square. Along AB. Okay. So the net electric field E equal to Q by 4 pi epsilon naught. This is equal to 4 AB. 4 x into d, and this is equal to x square minus d square, a plus b into a minus b whole square. So this is equal to x square minus d square whole square along AB. So it is equal to 2 into this 4D is divided as 2 into 2D, okay? So Q into 2D equal to magnitude of P, Q into 2D. So instead of writing it along AB, we can write it as a 2D vector, because AB is a vector along D. along 2D, along the dipole moment. So this is, you may take it as vector on 2D. Okay, so this is 2 into px by 4 pi epsilon naught x square minus d square. Okay, when the point P is far away from the center, that is x is much greater than d. When the point P is far away from the center, then we may neglect d in comparison of x. So E axial equal to, in that case it will become 1 by 4 pi epsilon naught, as we have neglected d square in comparison of x square. So we have x square whole square, that is equal to x to the power 4. Okay, so this is equal to 2 by 4 pi epsilon naught p by x cube. So this is the result when the point P is far away from the center of the dipole. Okay, in the next class we shall discuss about the electric field at the equatorial position. Okay.